So Alberto Ferrari, he's of the Ferrari family, but I'm not sure he's from the Ferrari family. But he hails from northern Italy. He's in town now. He's co-founder along with Marco Russo of sqlbi, and they've got just a great organization. They do training worldwide. I can tell you that when I'm at the MVP Summit, if Alberto or Marco is commenting on one of the presentations, the Microsoft people are taking notes. These guys have a lot of influence. They're between Alberto and Marco. They're referred to in our circle as the Italians, and everybody knows what that means.
Okay, we're gonna talk about budgeting with Power BI. Mainly, what I wanna talk about you. I'm not gonna present myself because Mark has already done an excellent job. So let's go straight to the topic. I'm gonna talk about how to work on a budgeting data model with Power BI. We are not gonna build a complete budgeting solution. Whenever we talk about budgeting, every company is an history by itself. So there's no way to build a complete budgeting solution. But I want to use budgeting as an idea to show you how to create complex and interesting relationships. This was intended to be the last slide, but I prefer to show it now so it stays in the recording. If you're interested in the demo files, you just need to scan this code. You should be able to do that from the recording, and that will bring you to a web page that contains all the files and all the stuff that I'm going to show. With that said, the idea is that we are at the end of 2009. We want to prepare the budget for 2010, and we want to do everything with Power BI. Now, I'm not a big fan of slides, so this is the last slides that we are going to show. The next one will be a thank you, and we do everything with a demo. The idea is to start with the data, play with it, and do some consideration, write some DAX, and end up with some working and interesting scenario. So let's start with the data model. I have quite a simple data model. We have sales, customer, date, product. This is data coming from Contoso. It's a fictitious company that sells electronics all over the planet. And this is coming from the data warehouse. So we have sales at the individual day level, individual customers, and product. And I added to this model a budget table. Actually, it's not a budget, it's a forecast of sales for the next year. The important thing about the budget is that sales coming from the data warehouse has a very detailed view of information. We have sales at the individual day level and product level. Whereas when it comes to budget, data is at a much higher granularity. The budget table is seen here, but it's tiny. I didn't have time, I cannot zoom in, so I prepared a report that contains the actual budget data. And for the budget, we have a much less granular data set. We have data only at the brand and country level. So for a datum in China, Germany, and United States, we have for the full 2010, 3 forecasts: the high forecast, the low forecast, and the medium forecast. Now, I'm just cheating here, meaning that in order to build those numbers, what I did was taking the sales of 2009, multiply them by a random number, and I obtain this number, which makes total sense. But in the real world, of course, this would be more reasonable forecast. Anyway, the important thing is that we don't have the forecast at the individual product level, or at the date level, or at the customer level. We have only large numbers which are forecast. And when it comes to build the data model, I'm a bit in trouble because I cannot easily, at least, build a relationship, for example, between budget and customer. The relationship between budget and customer exists, and it's based on the country region column, which appears here and there. But country region is not a key in the customer table. So if I build a relationship, as we will see, there are some issues that we need to worry about. Same happens with the product. With a product, the relationship would be based on the brand, which is a common column in both tables, but cannot be used to build a relationship in an easy way. Worse with the data. We know that the budget is for the full 2010, but what if I want to slice by month or by day or do any kind of reasoning on top of the dates? Budget does not even contain the data. It's just the full budget for 2010. What happens if I don't worry about relationships? Well, if I don't worry about relationships, what happens is that I'm not able to do any reasonable analysis. Here I have a report that contains the sales sliced by brand, and these are sales coming from the data warehouse, or from the sales table. But if I try to add to this my budget information, you see that the budget always shows the grand total. I can slice my budget by scenario, so we go for medium and the number changes, but it's still the same value for all the brands. The reason being, the filter on the brand is coming from product, and product does not filter budget because of a missing relationship. Instead of using the brand from the product table, I get rid of it, and I use the brand coming from the budget table. Let's turn that into a matrix. I have the opposite scenario. The brand from the budget correctly slices the budget, but it does not filter sales. Therefore, I need to choose where to make my mistake. So either it's sales, which is not filtered, or it's budget that is not filtered. Or I work in some way to fix the problem. The same scenario happens for the brand and for all the other columns. So for date, for example, I might want to slice by month name. Okay. January, February, March, this slices sales as expected, but it does not slice budget. So the first thing that we need to solve 3 problems, and we will use different techniques for the product, for the data, and for the customer. So we see many different ways of building these relationships. Choosing the right one then depends on you. The goal is to understand the pros and cons of the different techniques, and then it's up to you to use this knowledge to build your own solution. Let's start with the data. With the data, we have no information about the data. We only have a grand total for the budget. Remember, the data we start from is this data that says that in China, in the high scenario for a datum, this is the grand total over the year. Now, what's the problem of this? I need to be able to build a relationship between date and budget, but there is nothing in the budget that let me build the relationship with data. If I want to go at the month level, I can do that, but I need to increase the granularity of the budget table. So I cannot have just one row for the entire year. If I want to go at the month level, I need at least to have the granularity at the month level. That means increase the number of rows in the budget table, adding 1 row per month, which allocates the budget the right way. Now, given that I have $231,000 in China for the high scenario, the real question is, how much do I allocate for January? How much I am expected to sell in January in China for a datum? I know that I will need to split this value into 12 values, but I don't know what to store in each value. A simple solution would be to just take this number divided by 12 and allocate 1/12 of the total amount month by month. Well, I could do that. That would be, well, a suboptimal solution, because I would not be taking into account seasonalities which might exist in my data. So in order to understand this idea of seasonality, let's take a look at another report that I already prepared. It contains a lot of numbers, but they are not important to read. This report is showing the sales in 2009 sliced by country, region, and then brand. And without going into too many details, it's important to see that a seasonality exists. Look, for example, at China. In January, most of the brands do not have sales apart from Roseware, Contoso, and White Word Importance. In February, whatever the reason is, they don't sell anything at all. In March, they start selling anything. In April, they all wake up and they start buying as if there was no tomorrow. And then in May, sales slow down again. So there is some sort of seasonality. And if I only divide the number by 12, I'm losing this information. The seasonality is not the same over different countries. If we look at Germany, in Germany, sales are much more, they are better split. You can see that there are sales nearly every month, even though in April the sales are much larger. And this is America. USA, they always buy as crazy. So there are sales for every month. Even though the number changes, there is some sort of regularity. I don't want to lose this information. I want to use this information in order to split the sales over time of the previous year, of the next year. So the main idea is to use this data. And for example, take Contoso in January. It sells $7,000 in China. So if I take this $7,000 and I divide it by the total sales of the year, $1 million, that gives me a number which I can use as a weight to allocate Contoso in January for China. Contoso in Germany will be a different number, and Contoso in the USA will be again a different number, always computed as the ratio between the current month and the full year. So what can I do in order to take these numbers and use them in my report? Actually, I already have the information here. This report contains everything. The problem is that this report is what it is, just a report. And I cannot just use a report as a source of my data set. But I can build a query that produces the same result, and I will use it to build a calculated table that actually stores the information. Once I have my calculated table, I will be able to increase the granularity and use it to allocate the budget. Now, if I want to build such a query, I don't even think about writing in Power BI. The experience will be suboptimal, which is a very polite way of saying that it will be a nightmare. Instead, I can use DAX Studio. I just opened DAX Studio, connected it to my Power BI file, and I can start writing a query that reproduces my report. Now, the report is slicing by country, region, by brand, and by month. So I need to start reproducing the same query. And we will do that together one step at a time. It's a query, so it starts with evaluate, and then we need to summarize sales by, let me remember that, by country, region, by brand, by country, region, brand, and month. So we summarize sales by customer, country, region, and then by product brand, and for the month, since it's going to be a query, we take straight the month number. I run this query, you see that I already have my first result: United States Contoso January, then United States Contoso February, and so on. This is already good because it shows country, region, brand, and month, but I'm missing sales. What I have as a further information here are the sales in 2009. So I need to add a new column. Let's call it sales amount, which is the value of sales amount. You see that using DAX Studio, I can always format the code while I type it, and that's it. This is extremely useful because it makes it simpler to work with the code. Now I have my number. I have sales amount, United States Contoso. I need to restrict the filter to only 2009. So I need to add a calculate table around everything, where we use treat as calendar year 2009 as a date calendar year. What's wrong with you? I'm missing the curly bracket here. Not yet. Treat as, this closes, treat as, this closes our calculate table. No way. Okay, no. Curly brackets needed to be here and not here. Okay. So now I have United States, Contoso, month number, sales amount. 395 should be the number of Contoso United States in January. Let's give it a try. Contoso United States, January, it's 395. That's good. So it starts to produce a good number. Nevertheless, I'm not actually interested in the sales amount. I mean, I'm interested in the sales amount, but I will want to divide this number by the sales amount over the entire year. To obtain that, I need to have the yearly sales. And how do I compute the yearly sales? Well, I already have a filter by country, region, brand, and month. In order to obtain the sales of the entire year, I need to get rid of the filter from the month. So I calculate again sales amount, but I get rid using remove filters of the month number. Let me format the query in the meantime. And now you see that I have United States Contoso in January, 395 with the sales amount. The yearly sales should be 7268. As usual, we do a quick test. United States Contoso at the year level, it's 7268. So we are computing it right. Now I have in my data set sales amount and yearly sales. But if you think of that, I'm not interested neither in the sales amount nor in the yearly sales. What I really want is the division of sales amount by this calculate. So I can change it and say, well, I'm not interested in the sales amount. I want the percentage, which is just the division of sales amount by yearly sales. Close divide, format the code, run it, and now I have a better picture. This tells me that United States Contoso in January, I need to allocate 44% of the total budget. So I have the number that I wanted, and it's in a way, it's designed in a way that I can create a calculated table and use this information. But again, if you think a bit better at that, I'm not interested in the percentage. What I can do is one step further. I can take the value of the budget for Contoso United States, which I will find here in this report. For Contoso United States, this is the budget in high, low, and medium. So I can grab this number and multiply my percentage by this number. That would generate the value that I need to allocate for January. So I can do that. I can add a further column throughout columns, which is the budget. And I use lookup value. Lookup value requires me to specify the column that I want. It's the budget. And then I need to specify a set of columns that need to be one equal to the other. So I want the budget country region to be equal to the customer country region. Then I want the budget brand to be equal to the product brand. And then I need to specify the third key, which is the budget scenario. For now, let's make it simple. I only use the low scenario as a fixed string because I just want to see whether the code runs or not. And if I run it, this tells me that the budget, the full budget of Contoso low is 4510. Then multiplying this number by this number would produce the value to be allocated in January. That is cool, but I want to get rid of this fixed value low. The problem is that in my dataset, I still don't have the scenario. So I need to add the scenario to this summarize. I do that by cross-joining these with the values of budget scenario. I added to the entire summarize the values of budget scenario. So if I now run the query, you will see a new column appearing here, which is the scenario. This scenario is not yet changing the result here. To do that, I can simply replace this low with budget scenario. Now, it looks really weird to search for a row where the budget scenario is equal to budget scenario. The thing is that this is the column that I need to search into, and this is an expression that contains the value I want to search for. So even though it's the same syntax, the meaning, only because of their position as argument of lookup value, is a very different table. So my query now returns the percentage and the budget. Again, if you think a bit of that, I'm not interested neither in the percentage nor in the budget. I'm interested in the multiplication of one by the other. So I can remove all these and just multiply the values one by the other. So this will no longer be a percentage, it will be the allocated budget. Now my entire calculation says, well, in United States Contoso, for the scenario low, this is the value that you want to allocate. The query is already nice as it is. It's 24 lines of DAX code, not that complex. But I'm still missing one important detail. When I will create a table based on, I create a calculated table, I will want to build a relationship with date. Let's not forget that what I want to do is link budget with date. So I need the date in my table, and I still don't have it. But I have the month number. So I can create a new column, let's call it a date, which is a date in 2010 for the month, which is in the current row, and let's go on the first day of the month. I'll run it again. Now you see that we have Contoso, United States, in this scenario, in this date, and we always go the first of the month. This is the budget that we want to allocate. Now that my query runs fine, I can copy everything, go in Power BI, and now I can build a new table. Let's call it allocated budget. And I can simply pass the code that I wrote. Hit enter. And I end up having the table loaded in my model that contains all the numbers that I want, the different scenario, and everything else. While we are here, we spend a few seconds just formatting this data. And we can start building the relationship, because now this budget does not contain values which are allocated. This does. And I can build a relationship between budget, and we have a problem. You see that it says that the circular dependency was detected. Now, a circular dependency happens when the code that you use in the budget contains references to a possible blank row that might exist in the date table. And we need to search in the code for the presence of this. Where are we using the blank row? Well, we have this date, but that's fine. We have these remove filters. that might need to be an old no blank row. And these three tasks might be the problem. So we need to make it a filter over this thing. Date, calendar, year, where date, calendar, year equal 2009. The result is not going to change in this case. That remove the filter, that uses this thing. But by using this syntax, I should have removed all the references to the possible blank row. Now, if you are not familiar with the presence of blank row and how they affect the circular dependencies, there are a couple of articles at sqlbi that you can read, which are worth reading, because if you start building calculated tables to create relationships, it's going to be super helpful to be able to debug this code quickly. Okay, let's go back to the report. Yeah. And build a relationship between date and date. Now that we got rid of references to the blank row, the relationship can be created, and now date will be able to slice the allocated budget table. Let's see if it works as expected. I have the month, I have sales in 2009. This is still the old budget column. We can get rid of it. And actually, we can hide this table. We are no longer going to use it. Instead, in the allocated budget, we have this new column. And if I put it there and format it, it's already formatted nicely. I only need to add the comma. You see that it slices by month the right way. I still have this scenario. This scenario is still filtering the old scenario. I need to make it filter through the new scenario. Now, if I select different scenarios, I have my budget allocated by month the right way. So, what we have seen so far is how to create a calculated table that statically allocates the budget based on the sales in the previous year, increasing the granularity and building the relationship, which is good enough because it gives me a way of allocating the budget in a static way. But what I could do with the data, I cannot do with neither customer nor product. The reason is with data, I went at the granularity of the day, of the month, and I always went to the first of the month. I cannot do the same neither with customer nor with product. I cannot relate the budget to one customer in that country or one product in that category. That would lead to a wrong allocation of values. What I would like to do is build a relationship between the country region, between budget and customer. But country region is not a key here. And I have two ways of obtaining the same goal. One is to build an intermediate dimension here, an intermediate table that contains all the possible values for the country region so that it will act as an intermediate dimension here, relate both tables, and be able to filter both tables. And that's a possible solution. We are going to implement it in a second. The other solution requires creating a weak relationship between the two tables. Both have advantages and disadvantages. Let's start with the easiest one. Well, it's not the easiest one, but it's the easiest to manage and understand, which is creating an intermediate table here. As I did earlier, I'm going to create a calculated table that contains all the possible country region. So we go again in the model tool, we create a new table. This time there's no need to use a DAX Studio because the code is very simple. We build a table, country regions, singular with everything else, where I can just take the distinct values of customer country region. And I create this way a table containing, containing something, hopefully, yep, containing United States, controls Germany and China. That is already good enough. But what if there is a country region in budget which does not appear in customer? What I can do is use union and say, okay, give me the distinct from the budget country region and the customer country region, and then union together the two results. So it doesn't matter from where the country region comes from, I will be able to show them. The problem of this is that union in DAX is a union all. So now I have United States duplicated, China duplicated, and Germany duplicated again. That's not a big deal. We can distinct it later. So I have the union that contains duplicates, and I include everything inside a distinct that gets rid of duplicates. So now I have my table, and I can, well, search for it. Where are you? Here. And I can build a relationship. Country region filters country region, and the country region filters country region again. So now I have this dimension, which is able to filter customer, therefore sales, and it's able to filter the allocated budget. But I need to use this country region instead of using the customer country region in the report. So here I have the month. Let me get rid of the month. If I use the country region from customer, as you're going to see, nothing is going to change. The budget is not yet filtered. If instead I use the country region from the country region table, that will filter sales and budget at the same time. So a good practice at this point is to hide the country region from here, so that the user is not expected to slice by the customer country region, but it can only slice by this customer country region. That's a first solution. It works nice, and it's also pretty fast because this relationship is based on small columns, which are very fast to move filter back and forth. We still need to solve the problem with the product table. We could use the same technique. So build a table containing the brands and build a set of relationships and make everything work. But since we are here to learn, we can use a different technique. What if I try to build a relationship between brand and brand? It is not a key in product. It is not a key in budget, but maybe Power BI is able to do some sort of magic. So we can try to build a relationship. And well, Power BI raises a warning. I love this warning. It says the relationship has cardinality many-to-many. This should only be used if it is expected that neither column contain unique values, which is our case, and that the significantly different behavior of many-to-many relationship is understood. Now, this error message basically says, if you understand something that I'm not willing to explain you, then you can click on OK, otherwise you're on your own. I don't know what you do when you see a warning, a yellow message that you don't understand, but I typically just click OK and go ahead. So what happened? It generated a relationship that has the many side on both sides, and it's also a bidirectional many-to-many relationship. I don't know what you think about bidirectional relationship, but I know what I think about them. They are the evil. Never use a bidirectional relationship unless you really, really know what you are doing and you really, really need it. The thing is that in this case, the engine had to use bidirectional because the cross filter always goes from the many to the one side, from the one to the many side. And in this case, because both sides are the many side, the engine doesn't know which table should filter what. So it uses bidirectional by default, but we can change that. If we double click on the relationship, we can choose the cross filter direction between filters that product that filters budget or budget that filters product. What we want to happen is that product filters budget. We click on OK. And now product will filter the budget. So now budget is being filtered by by country region, which filters customer and budget. It's filtered by data because we allocated it statically, and it's also filtered by product. Let's give it a try before going further. I can slice by country region, that is cool. Can I slice by brand too? I can take the brand from the product table, put it in my matrix, expand it, and actually it works just fine. You can see that I can see the details by product and by country region, and slicing is happening in a nice way. So what I have done so far, I had two tables at different granularity, and I wanted to slice them through the same set of dimensions. And we have seen three different techniques of doing it. One, to allocate it statically using DAX or Power BI or Power Query, choose the tool you like the most, but we have done it in a query. Using an intermediate dimension, we built it in DAX. Again, you can do that in Power Query. There's nothing preventing you from doing it. And it works easily. It's based on physical relationships, so it's very fast, but it requires the building on an intermediate table. Or we can use weak relationships, many-to-many relationship between attributes of different tables. It works. The behavior is very close to the intermediate dimension. It's a bit slower because it's solved by formula engine and not by storage engine queries, but it's very simple. And it works out of the box. You only need to pay attention to the relationship and the direction of the cross filter. Still, my problem is not completely solved. I now can slice by using the attributes at the granularity of the budget. But what happens if my user browses to a deeper level? So it says, well, for country region it works, for brand it works. Does it work by color too? And it turns out that it doesn't. If I slice Contoso, you see that sales is still sliced by color, budget is not. It goes on repeating the same number again and again. And the reason is that the filter between the product and the allocated budget works at the level of the brand. It cannot go below the brand. This might be expected and by design. So you might say, well, I don't want to go farther than that. My users are expected to browse only as long as the granularity is supported. Going deeper would produce a meaningless number. Nevertheless, you need to pay attention because users are able to do any kind of damage with a model that always produces a number. The problem is not when the number is the same as in this case, because nobody is that stupid not to understand that the same number repeated again and again is indeed an error. But what happens if I remove the country region, for example? So I get rid of the country region, I get rid of the brand, I only slice by color. Now you see what happened. If I only slice by color, I see numbers, all these numbers are wrong and they are all different. So it's not so easy for a user to understand that they're actually wrong. They might be right or wrong, but it's not evident. What is happening here is that the filter between the tables is passed at the granularity of the relationship, in this case, the brand. So this is the budget of any brand that contains a product which is azure, any brand that contains a product which is black, any brand that contains a product which is blue, and so on. The filter on the color is transformed into a filter over a brand before being moved to the target table. We need to fix it. We need to make sure that okay, let's cross the fingers because let's save the file because I just got an error. We need to make sure that this number, instead of being repeated, is either shown as an error, blanked out, or fixed in some way. Doing that requires some attention because I need to be able to understand, I need to be able to discover when I'm slicing the budget at a supported granularity and when I'm not. I need to distinguish between this row and this row. And to do that, I need to inspect the filter context and understand the level of granularity that I am currently browsing my model. How do I know that? How do I discover it? Well, one option is that of checking column by column what is filter and what is not. It works just fine, but it's incredibly boring to write because you need to check column by column to verify which are filter, which are cross filter, and if you can reasonably show the number or not. So it's easy but boring. If you want to do something more exciting, well, you need to think a bit more. How can I distinguish when I'm slicing at the granularity of the budget and when I went too far, when I expanded my hierarchy too much? One way is just to count the number of products. So I can build a measure. Let's put it here. Let's call it number of products. It was number of products, which is just a count rows of product. And then I put it in the report. Look at the numbers here. Now, for China, the budget is 200,000, and there are 132 products for a datum. What is the meaning of this 132? Well, the meaning is if a datum is in the filter context, a datum contains 132 products. So if you see 132 products, it means you are at this level. If you see a smaller number of products, it means that there is a further filter which is restricting the number of products. So you are seeing fewer products than the one that the budget supports. So even though sales will report a correct number, the budget will not, because the budget will still report the value at the granularity that is supporting. So if I was able to compare 14 with 132, if the two numbers are the same, that is fine. But if the two numbers are different, I need to hide the budget. Number of products is fine. I need a new measure that reports 132 for all the rows of a datum. That requires a bit more DAX. It's not more complex DAX, it's just harder to understand. I need to write the products at the budget grain. And I need to do that by using calculate number of products. I remove filters from the product table. But I restore the values of the, where is it? Brands allocated budget, not from the, no, remove filters for the product and it uses a product brand. So I get rid of any filter from the product and I restore the value on the brand. This will get rid of the filter from the color and from the brand, and this will restore the filter only on the brand. Let me see if this is correct. Now you see that the value for a datum returns always 132. Now I only need to compare this value against this other value. If they are the same, I show the number. If they are not, I hide it. So I can go, I need to build a measure on the allocated budget. Let's call it corrected, no, let's call it protected budget. It says if the number of products is identical to the number of products of budget grain, then I return the sum of the allocated budget. Otherwise, I will just return a blank. This measure, once it's formatted as a decimal number with commas, and projected in my report, I need to get rid of this empty. You see that it shows a value for a datum and it blanks the value everywhere else. Now, I still see a lot of values here, but I now can start getting rid of the useless calculation, temporary calculation. I don't want that. I don't want that. I only want the allocated budget and the protected budget. And you see that while allocated budget repeats number, protected budget blanks it out. I can now get rid of my allocated budget and I obtain a solution which is already better because it is showing the budget if it can be shown, and it hides the value if the budget is at a granularity which is not supported. So this technique works already fine because it gives me the capability of showing or hiding the budget, showing it only when it will produce a correct number. Of course, I have done in the demo the calculation using the product. You need to repeat if you want to implement it in the real world. You need to repeat the same calculation also for the customer country region. I'm not doing it just because it would take useless time. But you will find the complete solution in the demo. The last step that I want to do is, doing one step further. So now I'm blanking out the value if I cannot compute it, or if I'm not sure that I can compute it correctly. But can I do anything better than that? Well, imagine that if I was forced to put a number here, could I do that? Actually, the answer is yes, I can. Because I know the sales in the previous year. I know the sales at the budget granularity. If I divide this number by this number, I obtain a percentage that I can use to multiply this budget. How can I compute this percentage? Well, the same way I computed the number of products. Let's start by building the percentage. The percentage that I want to use divides sales in 2009 by the value of sales in 2009 at the budget grade. So I compute sales in 2009, I get rid of filters from the product table, and I restore the filter over the product brand. I format that as a percentage. And if I wrote it correctly, I can now take the percentage, drop it here. And this is telling me that for Asia, for a datum in China, you need to allocate 16.76% of the total budget. When I reach the granularity of the budget and above, I always see 100%. Below the granularity, I see the percentage that need to be allocated for that value. Now that I have this number, all what I need to do is multiply the protected budget by this value. So in my protected budget, I can get rid of this condition, which is no longer useful. It was for a while because we were learning, but now that we know how to allocate the budget dynamically, we can simply take this and multiply it by our percentage. As soon as I do it, you will see that the budget shows a number, even if I slice it by color. And this number represents 16.76% of the grand total. This is 11% of the total. This is 3% of the total, and so on. Of course, at this point, I can simply get rid of my percentage. And the nice thing about this technique, it doesn't work only for the color. If I get rid of the color and instead I slice by category, and I expand, for example, Contoso, it is still computing a reasonable number, allocating in a dynamic way by category instead of allocating by color. Because the allocation is totally dynamic, I can slice by whatever I want. Keep in mind, by doing that, I'm just creating numbers out of nowhere. So if you ever do that, you need to make sure that your users are happy with those numbers. But to be honest, these numbers have a meaning and they can be explained. And as I told you at the beginning, I'm not interested in building a complete budgeting solution. My goal is to show you techniques that can be useful in budgeting. So you can use this as a tool to help budgeting people build a more reasonable forecasting system. One thing that is important is that this measure, as I wrote now, is not correct. In order to do allocation correctly, what you should do is a more complex formula, which is very close to this, but need to always go at the correct granularity. So the correct formula would be sum x over allocate filters over the cross join of values of product brand and values of country regions of calculate of all this. Now, I just wrote the code without explaining it because I was more interested in showing you the code than in commenting it online. This calculation basically forces the entire calculation to always go at the granularity of the budget. You cannot do the calculation above the granularity, because if you do that, you will not respect the different data distribution that exists in different countries. You always need to, when you do calculation at different granularity, you always need to force a calculation at the lowest level of granularity, do the math, and aggregate the values later. If you don't do that, the numbers will be just wrong. They are right, they are totally identical so far, but if I remove the country region, the numbers are now meaningful. If I compute them using my cross join, they would have been slightly wrong in the version that I used earlier that did not go at the correct granularity. Keep in mind, I'm always scared by something like slightly wrong. There is nothing like slightly wrong in the world, of numbers at least. A number is either right or wrong, and slightly wrong or almost correct is a polite version of saying wrong, but I don't want to tell you. Whereas this formula just produces the correct number no matter how you slice it, how you compute the value. Now, looks like I ended my time, but I also ended all what I wanted to tell you about the budgeting, because what I wanted to show you is basically how to build the relationship in different ways. And before we leave the topic, it's worth to note that even though it was very nice and educational to see the creation of this allocated budget, you remember the monster query that computes the budget in a static way, all the work that we have done in this part is basically useless. Because, as I said, it was useful to learn the technique, but once you learn how to dynamically allocate the budget, no matter what the user select, you can do the same for date too. You simply add the column containing the year, you build a weak relationship between the date and the budget, which only contains a column with the year. So there will be a weak relationship with date, a weak relationship with product, and either a weak relationship or a bridge table in the middle with customer. And then you dynamically allocate everything. Because the budget is not a large table and the granularity is just produces small tables, performance-wise, this works just fine, and let you allocate the values the way you prefer in a very dynamic way. The only really important detail is pay attention to the granularity. You will find all the formulas in the demo. My goal here was to explain you the technique and give you an idea of the kind of solution you can find. The more clean formula is not what I wrote here, but what you will find in the demo file. So if you are interested, just go there, download the file, start playing with it, and then be creative, because this is just the starting point of a more complete solution that you can create by yourself. Okay, that is what I wanted to show you tonight. So it's time to go for the last slide, which is the thank you slides for staying here listening for 1 hour of DAX code, which might be utterly boring or exciting. That depends on how much you like DAX. And that's it. Thank you for having been here. If you have any kind of question, just start typing in the chat or take the microphone and ask for a question, and I'm here for you for a while.
Thanks so much, Alberto. That was really interesting, and had nobody leave in the middle of the meeting.
Yeah, there is.
It's amazing. So there are a couple of questions, but we can either do it with chat or you can unmute yourselves, and I'm not sure if you're able to do that. So can somebody take a crack at it who has a question? Can you unmute yourself?
I'm sorry for that. I wasn't looking at that.
You can hear me, right? Alberto, can you hear me?
I can hear you, Mark.
Okay, great. I assume everybody can then. So, Bob, you're able to unmute yourself. So, Cesar,
the code
you've
for
got a
download.
question.
Yes, let me find it. Here it is.
It seems Alberto is not hearing us.
Yeah.
A visualization with the forecast data. No, if you're interested in visualization with forecast, what I can tell you, if you just Google, well, that's Microsoft. If you Bing, you first Bing, you don't find, and you Google for forecast actuals in Power BI, there is an article that we wrote which contains nearly the same model. Here I used weak relationships everywhere. So here the calculation is completely dynamic. There is no materialization of the code. And it also shows nice technique. This is, for example, is a year-to-date of the budget mixed with the actual. So it's showing in the same chart the actuals as long as there are sales, and then as soon as sales finish, it starts correcting them with the forecast, which is pretty cool, because you see this is the year-to-date of sales after the last date with sales, and then it starts, that would be the standard year-to-date, which stops, whereas the red line is showing the forecast from this day afterwards, and that this upper line is a corrected version of the forecast, because sales have always been higher than the forecast. From the last day with sales, we start producing forecasts corrected by the percentage of error we had at the beginning. And also in this case, you can download the file, look at the code, and get an idea of the kind of calculation we have done.